All right, so the topic of string is almost completed with respect to the data structures. Now we are going to talk about lists, tuples, sets, and dictionaries. You may be able to see that the lists, tuples, and sets, they all are in same color, but dictionary is a bit different. Yep, that is deliberately done, not a mistake. So the thing is, lists, tuples, and sets, they have, tiny difference between them. So let's study these three data structures first, one by one. And then after studying all these three data structures, we will have another video that will show you the difference between the summary of difference between all these three data structures. So while studying these three data structures, if you are a bit confused or you say, okay, this we can do with tuple as well, this we can do with list as well or set as well, yeah, maybe we can do that, but wait for the final video where we will show the difference, the summary of differences between all of these three data structures, right? So let's get started with the lists. So you can say that list is one of the most commonly used data structures in Python. Tuple and sets are not that commonly used, but list is very commonly used, right? Okay, for all these three data structures, we can store multiple values in one variable, like just like string. Where's the string? So here we have the string, right? In the string, in one string, we can store multiple characters, 10 characters, 20 characters, 1,000 characters, or more than that as well. Same goes out over here. What if I have to store, let's say, 10 integers in one variable, which means, let's say, those 10 integers belong to the same category. Let's say I have to store the age of people. Let's say I have 10 people in my class, in my office or somewhere. I want to store their age. So I'll say there is a variable called ages, and obviously the famous assignment operator. Then these square brackets. Remember, every data structure has its own symbol, just like string's symbol is quotation marks. List's symbol is, yep, these square brackets. Okay, that is one thing to remember. First thing is, list is represented by the square brackets. Secondly, since in the string, we have to have the continuity of the characters. So characters are not separated from each other by using any particular separator. But in list, we have a particular separator which is called comma. So two values are separated by comma. For example, we wanted to store the ages of people, right? So let's say if the ages are 12, then we have comma, right? And then it is our, it is our choice if we want to add the space or not. I would prefer to add the space just for the sake of readability. Then 15, then 19, then let's say 7, let's say 0. And we can also have negative numbers as well, but since in the age we cannot, negative is not considered as any age. So let's skip that and let's say 90. Okay, how many? Okay, we have 6 numbers over here. So 12, 15, 19, 7, 0, and 90. This is how we define a list. And if I say show ages over here, so here we go. So we have this list. Okay. Now rest of the functions of slicing, indexing, and everything is exactly same that we studied for the strings. For example, if I want to access this element 15, you tell me what is the index of element 15. Indexing start from 0, right? So 12 is at 0th index, 15 is at first index. So if I want to access 15, I'll say ages, which is the variable name, then the index operator, and then I'll say 15, right? No, that is wrong. I should say 1. 15 is actually the element. I want if I want to access it, I can access it by using the by using its index number. So running it, here we go. We have 15. Okay. Okay. One more thing. This ages. If I'll say what is the type of ages, so the type of ages is going to be list. Okay. But if I am accessing a particular element of the age, this is very important thing. So please pay attention. If I'm checking out the type of the whole data structure, that is list. Yeah, that is for sure. But if I'm accessing any particular element of this data structure, which is this element is not a list. Well, these whole elements are list, fine. But this particular element individually, it is a numerical number. It is an integer, right? So if I'll say check out the type of this whole thing, so you see, this is an integer. So the moral of the story is, when we access any particular element, let me show this element over here. So ages. Okay, coming back to the point, when we access any particular element by using indexing operator, then that element becomes its own data type. It goes into its original data type. For example, if this is a integer, it shows it is an integer. If this would have been a floating point value, this would show the floating point value. For example, let's have a floating point value, 19.4. Okay, run it. So now we have 19.4. But where is 19.4? It is at 0, 1, and 2 at second index, right? So here, if I say ages of 2, so it says 19.4. And if I go here and I say, what is the type of ages? It says float. Okay. Now, this verifies one more thing. A list can contain values from different data types as well. This is point number 2. Point number 1 was a list is denoted by square brackets. Point number 2 is list can contain multiple data types as well. Okay, if that is the case, can we have a string over here as well? Let's have it. So if I say hello, run it, hey, no error, which means that yes, we can have a string inside a list as well. It is not necessary to have it at the end, but yeah, you can have it in the middle, in the beginning, wherever you want. Okay, cool. Now, if I want to access this string, what should I do? I should say 0, 1, 2. That's a long thing. So I'll go with a negative index. Negative index is -1, right? So ages, if you're not familiar with the negative indexes, please watch previous videos regarding strings in this module. So if I say ages -1, so -1 is the negative indexing that starts from right hand side. So ages -1 is hello. Okay, fine. Just to verify, what is the type? What is the data type of this ages -1? So it is a string. Okay. So I hope this thing is crystal clear now, that each element of any particular list is a different, can be of different data type, right? Okay, now, interesting thing. If I say -1, it will get me hello, which is this string. Okay. Now, since this is independently another string, can I append another string into it? So for example, can I say something like hello word? Yes, I can do that. Why? Because it is a string, and I can concatenate string with another string. Okay, fine. This is one thing. But another interesting thing is, if this is a string and I want to access this E letter, how can I do that? Remember, ages is not the string. Ages of -1, by the way, when I say of, it means these square brackets. Okay, so ages of -1 is the string. Okay, so this whole thing is the variable name. If I want to access E, I'll have to further index it, which means, I'll add another indexing operator, because remember, this is a complete string, right? And if I want to access E, this is at first index, I'll do something like this. Okay, so where is the original list? Okay, so here we have a list, which is a data structure. So in one data structure, we have another data structure, right? So if we want to access the inner data structure, element of the inner data structure, we have to use multiple indexing operators. I hope this point is crystal clear to you guys. Okay, so let me revise 2 points. List is denoted by square brackets. List can contain multiple types of values, multiple data types of values. By the way, list can contain another list as well. For example, like hello, And here I can add another list. Okay, so this list can be of, let's say, 1.2 comma 60 comma maybe another string. Well, let's do it like that. Let's say ABC. Okay, this can also work, right? Now, if I want to access 60, where is 60? First of all, 60 is at the last element of variable ages, right? So I'll say ages of -1. That will get me this whole list. And then of that ages of -1, and then I'll go again to 1, right? Just like this. That will get me 60. Okay. So coming back to the point. First thing, list is denoted by square brackets. Second, list can contain multiple data types. And third, and the most important point to remember that will make this list different than the others is lists are mutable. What do we mean by that? Mutable means we can change any element of the list anytime. Well, we do not have this facility for every data structure. I'll show you in a minute, but let's try it with the list. For example, the first element of the list is 12 for now. Okay, I want to change it. I want to make it, rather than 12, I want to make it 999, 999. Okay, so right now, if I show you ages, this is how the ages looks like, right? And if I say ages of 0, it gets me 12. I want to replace 12 with 999. So what will I do is I'll say equals to assignment operator, right? So I'll say, hey, update the value of ages at index number 0. Not at every index, but only at index number 0. Okay? And let's do that. Nothing happens. Why? Because I did not print anything. It is just an assignment operation going on. So I'll say ages, go on, here we go. Now first element is 999. It is not 12 anymore. If you're worried that why it's 12 over here, because this cell was executed before this cell. Now if you will execute this cell again, it will show 999 over here, but I will not do that so that you can have a look at the difference. Okay. So lists are mutable. You can change the values inside the list. Can we do that with strings? Let's try. Okay. So here we have a string. Okay. str1. So if I say str1 of 0, which is going to be B, I'll say, okay, equals to, I'll change B with what should I change it with so that it still remains a word, L-U-E, clue, right? C-L-U-E. Oh yeah, great. Let's change it with C. Running it gives me an error. It says that string object does not support item assignment. So we cannot change any particular item, any particular element inside the string, which means that strings are immutable. Lists are mutable. Okay, this is kind of a flexibility that we have in the list. Although, if I really want to change this from blue eyes to clue eyes, I can do that. How can I do that? Let me show you. I'll say str1 is equals to, I'll write a new string over here. So clue eyes. Okay. Now what will happen if I say str1? Now this variable was pointing towards blue eyes, the string that was there in the memory that says blue eyes. But the moment I did this, I say, hey, the same string that were pointing towards blue eyes, you go ahead and start pointing towards clue eyes. So now it is pointing towards clue eyes, and this blue eyes has gone. I cannot access it anymore. So you can say, illusionally, I am able to update the elements, but actually, really, realistically, I'm not able to update the elements. I'm just able to update the whole variable. But with the lists, I can update each and every element of the list. Lists are way more powerful. We will probably talking about lists more than anything else. So right now I'm going to pause over here about lists, and let's talk about the other data structures a little bit, and then we'll come back to the lists.